So we're going to start Unit 7, Chapter 27, a little bit different than what we've been doing before. And we're going to start by doing a little bit of review because we're going all the way back to Chapter 8 and we're looking to make inferences on linear regression models. So we have to dig back those sentences that we had for writing out slope and y-intercept. We have to dig back that sentence that we have for writing r squared, which is the coefficient of determination, if you remember that correctly, as well as all of our assumptions and conditions for graphing lines. So let's start with a problem. We'll jump to the calculator and refresh our skills on doing a line of best fit and the analysis, and then we'll do a preview of what we need to do in order to make inferences off of linear regression models, because maybe we want to make conclusions not just from this sample of data, but to the whole population of data, which is what we've been doing. So in this case, and it might sound familiar to you guys, new state requirements force students to take high-stakes math tests in order to graduate from high school. This is happening in New York State. Faced with such a pressure-laden situation, many students become very nervous, which may interfere with their ability to perform. Concerned about test anxiety, a researcher enlists 24 student volunteers for a study. A psychologist interviews them before the math test, assessing their anxiety levels on a scale from 1 to 10. The table, which I have typed into the calculator already, shows the anxiety levels and then their subsequent exam scores that they got. So this worksheet is going to walk us through entering the data and then doing our linear regression model. And as you recall, what we need to do before we check anything is do our assumption. Have we met our assumptions and conditions? So the very first one that we need to check is, do we have quantitative data? Before we do anything, are anxiety levels and math test scores both quantitative variables? That meets our first condition. So we're going to jump to our calculators and actually build the model and then make sure that all of the subsequent conditions are met. So as we move to the calculator, you can see that I have already typed in all of the values for the 24 students that volunteered. So once we have our data and we have anxiety as column B, math test as column C, what we are going to do is we're going to add a document. So I'll hit Control Doc and we'll do data and statistics. And then we'll click for our explanatory variable. We have our anxiety level, and our response variable is going to be our math test scores. And as we can see, and if we recall the sentence that we need to write from chapter 7, we have a mostly linear negative slope line of best fit. And if we want to actually get the line of best fit, we hit Menu, and then we go to Analyze, and then we go down to 6 for regression. And I'm going to choose A plus BX. You might be most familiar with MX plus B, but we're going to use A plus BX. And so we get our slope equation, and I'm just going to drag that to the side. So we have a y-intercept of 91.65, and we have a slope of negative 4.48. If I go back to my spreadsheet, I can do the exact same thing. So if I'm just going to move one column over, I'm going to hit Menu, and we're going to go to Statistics, and we're going to go to Stat Calculations, and we're going to, again, do a linear regression. So we want anxiety for our explanatory, or X, and we want math test to be our Y, and then I can just hit OK. And again, we see that our y-intercept in this case is 91.65, and our slope is negative 4.48. If we look at our scatter plot, there is a weak negative association between anxiety level and math test score. The correlation between the scores is only negative 0.525. And we get that by going down to our R value. So our R value is calculated from our stat statistics. So back to our worksheet. Does there appear to be an association? So we're going to write our sentence. And if you need a refresher, this is what we need to write from chapter 7. So next up, it says find R. From our calculator, we have R to be negative, which makes sense, 0.525. And what does this correlation mean? So generally, lower anxiety levels are associated with higher math test scores. And our R value tells you how well our model fits our data. Before we check R squared, we want to make sure that we look at the other assumptions and conditions. Much like we did, once we check that we have quantitative data, is our line of best fit and our model straight enough? And our data was linear. Next, we should look at our equal variance assumption. And if you recall, if we go back to our scatter plot, what we should look at along with our line of best fit is if I hit menu, if I go to analyze, and I go down to 7, I get my residuals, and I want to show residual plot. And if you recall again from chapter 8, we want to see no discernible pattern from our residual plot. So we look at the residual plot and we check for changes in the spread of the residual plot. We want to make sure that this is uniformly scattered and random. Lastly, we want to make sure that we watch out for outliers. And if we look at our scatter plot here, we have this one really low value. So one of our students had an anxiety level of 4, but they got a 29. So is this a point of influence or leverage? And this is a standard anxiety level score. So this is not going to have too much influence on our line of best fit. So there is one student who scored much lower on the math test than we would have suspected based on the student's anxiety level. This point is close to a typical anxiety level, so it shouldn't prove to be particularly influential. Now, if this student was at 0 or also at like a high 10 and they scored really high, then it would have more influence. But this is more of a typical score that people had. So both variables are quantitative. The scatter plot shows an association that is roughly linear. And so with our linear model, we had our math test. So I'm going to write math hat equals 91.66 minus 4.48 times anxiety level. What we also want to look at is our R squared value. So again, we're going to pull up what does R squared mean and what we should write. Now remember, R squared, or the coefficient of determination, is talking about the percent of variation that's accounted for. So we're just going to fill in this sentence. So our R squared value here was 27.56, and that's a percent. So that means 27.56% of the variation in math test scores is accounted for by the variation in anxiety levels. So we have our linear model. We've looked at the R squared, which is somewhat low. We looked at our correlation coefficient, which tells you about the strength of our association. And then it says, is a linear model appropriate? Create and discuss the residual plot. So again, if we look at our residual plot, we see that it's scattered appropriately. And because it's scattered and there's no discernible pattern, our model is appropriate. Next up, we're going to interpret the slope of this line in context. So again, pull up that sentence that we need to write for our slope. For every additional blank in blank, there is an increase or decrease of slope in the response variable. We will write, in this case, for each additional unit of anxiety level, the model predicts, there's our squishy words, a decrease of about 4.5 points in the math test score. We also look at our y-intercept, which means a student with 0 anxiety is predicted to score a 91.66 on the math test. So the last question says, does this prove that anxiety interferes with students' performance? So if we look at the residual plots, it does have random scatter, indicating that our model is appropriate. We already know that from way long time ago, all models are wrong, but we're just looking for something that's good enough. The one thing that might worry us is this low R squared, this low variability. And because that R squared is low, this makes the model a poor predictor of the math test scores. Now, the only other thing that we really want to think about is, so we do see that there is an association for these students, but this is just one sample of 24. What if we wanted to look at all of the samples that we could possibly take from from the students that take this test? Is anxiety a contributing factor to people's math test performance? And this is where inferences come in. This is the focus for chapter 27, which is the last unit that we will be covering in AP Statistics. One word of caution before I leave you: like everything, association is not causation. We're not saying if someone has high anxiety that they will have lower test scores. We're just saying there is an association between these two. So always keep that in mind. So with that, we'll end this example, and we are going to then jump straight into the notes with the next video.